Hey guys, so here we are with the question third of the exercise 1.3. So the question third is prove that the following are irrationals. Here we have been provided with the three numbers in part A, B and C, and we need to prove that these numbers are irrationals. So let us start with A. That is, here the number provided is 1 by root 2. And as we know that root 2 is an irrational number. How we can say that root 2 is an irrational number? By using the method of contradiction. That is by following the same method as we have used in solving our question first. Root 2 can also be proved that it is an irrational number. If root 2 is an irrational number, then definitely the reciprocal of an irrational number is an irrational number. Which means that on taking the reciprocal of root 2 will result into the number 1 by root 2, which will be an irrational number. Now coming to the B part of this question, here the number provided is 7 root 5. And as we know, root 5 is an irrational quantity, as we have proved in question first of our videos. So if 7 is being multiplied by an irrational number, then the number resulting will definitely be an irrational number. But if we want to do it by following some steps, then we can prove it by using the contradiction method. So in contradiction method, we will first assume that 7 by root 5 be a rational number, which means it can be expressed in the form p by q, where p and q are some integer and also these are co-prime numbers. Means the HCF of p and q is equals to 1. And we can also write root 5 is equals to p by 7q, where in numerator p is an integer and in denominator we have the number 7q, which is also an integer. Means we get the form of integer divided by some integer. But as we know, for the number to be a rational, only the number should express in p by q form is not sufficient. That is the condition that the number can be expressed in the form p by q, or we can say integer divided by integer is not sufficient for the number to be proved a rational number. There was another condition as well. What was that other condition? That the number p by q, that is the number in the numerator and the number in the denominator, have their HCF is equals to 1. But clearly we can't say anything that whether or no they have their HCF equal to 1 or no. Which means that we cannot write directly by seeing the integer divided by integer form that this is a rational quantity. We need the another condition also to be fulfilled before declaring it to be a rational number. But as we have proved in the question first that root 5 is a irrational number. So if in left hand side we have an irrational quantity, then it will definitely result into the right hand side a irrational number. So which means that 7 root 5 will also be an irrational number, as this was being simplified form of the number 7 root 5. In C part, we have been provided with the number 6 plus root 2. Again, in order to prove whether or no this number is rational or irrational, we need to follow the contradiction method. What it means is that we will first assume that 6 plus root 2 is a rational number, which means it can be expressed in the form p by q. Or we can write it as root 2 is equals to p by q minus 6. Now taking the LCM q in the numerator we will get p minus 6q. And as it is clear that in the numerator definitely there will be some integer quantity, as all the entities, or we can say all the numbers, that is p, 6 and q involved are integers, and the arithmetic subtraction, addition and multiplication involved in some integer will form another integer. Let this be any integer, say p1. So in numerator we will definitely get an integer quantity, and in the denominator there is q, which is an integer. But we can't say clearly that this is a rational number, as only the condition 1 is satisfied, that is, it is expressed in the form integer divided by integer. But the another condition for the number to be rational is that these integers, that is p1 and q1, needs to have the HCF equals to 1. But we can't say directly from this that it has a HCF equals to 1. So which means that we can't write it directly that 6 plus root 2 is a rational number. But we do know that root 2 is an irrational number, as we have proved by using the contradiction method. If on left hand side we have an irrational quantity, then in right hand side definitely we will have an irrational quantity. So which makes us to conclude that 6 plus root 2 is irrational number. As root 2 is equal to integer by integer has also been derived initially from the number 6 plus root 2. So 6 plus root 2 is irrational number. So this is how we can prove that these numbers provided are irrational numbers. I hope this question is clear to all of you.